Hi everyone. In the previous video, I have asked 3 questions. In this video, I am going to answer all those 3 questions. The first question was why any property is a function of 2 variables and specific set. If you remember degrees of freedom, the equation for degrees of freedom, that is Page rule, C minus P plus 2. C is the number of components and P that indicates number of phases. Whatever we are going to do, that is for pure system, single component, single phase. So here everywhere it will be number of components would be 1, number of phases would be 1, and degrees of freedom would be 2. It is bivariant. The meaning is you can decide any property as a function of 2 variables. That's why each property is a function of 2 variables. Other thing is why a specific set of canonical variables has been selected. Okay, if you remember the equation of enthalpy, this was the one fundamental equation. Here there are 2 canonical variables, S and P. And why we have selected these 2? Why not other 2? As if when we are writing an equation for enthalpy, then why these 2 variables have been selected, S and P? Okay. Here, let me write the. I can assume that H is a function of 2 variables S and P. And if I take differential of this equation in terms of partial derivative, then it would be del H by del S at constant P ds plus del H over del P at constant S dP. If you compare these 2 equations, then the first partial derivative is equal to T and the second partial derivative is equal to V. The meaning is, if you know the 2 variables, the values of 2 variables S and P, then you can easily obtain other 2, temperature and volume. Means we have selected such set of canonical variables that just by partial derivative we can get other 2 variables. Okay, let's take the reverse. As for example, I am considering H as a function of other 2 variables S and V. So here the 2 canonical variables are S and V. The other thing is, in this case, if I want to calculate P, in earlier case S and P were 2 canonical variables and we obtained other 2 variables T and V just by taking the differentiation of enthalpy with respect to something. But here, if I am considering S and V and I want to consider the value of P, I want to calculate the value of pressure, what I will do, I can consider this equation because volume is one canonical variable I have selected. To get the value of pressure and the value of volume is known, I cannot take the partial derivative. I will have to integrate this equation. So it would be like dH equal to VdP. If I want to calculate the value of P, and I can write V as a function of pressure, and I can integrate this equation. While integrating this equation, there would be one integration constant. When you integrate this equation, integration constant, and to get the value of this integration constant, I need any one value of enthalpy at specific pressure, and that is unknown because everywhere we are going to calculate the change in particular property, right? So here to get the integration constant, I need one value of enthalpy at some specific pressure, and that is unknown. Due to that, I can say that choosing S and V is not appropriate for the complete definition of all properties. It is not going to define all properties. That's why each property is written as a specific set of canonical variables. I have just given the example of enthalpy. You can check about dZ, dA as well as du. When you simplify in this way, you will always get other two variables as a part of partial derivative. Okay, so this was the answer for the first question. I am going to cover other two questions. Why there are four equations and which is more fundamental? If there are four fundamental property relations, which is more fundamental? The answer of these two questions is each equation has equal importance. There is not any single fundamental equation as compared to other three equations. And which equation I should use when, it depends on. As for example, I am taking the equation as for enthalpy is a function of two variable S and P. Gibbs free energy is a function of T and P. Each property is a function of specific set of two canonical variables. Which equation? There is no any single equation more fundamental than other three, and it is like it depends on your problem statement. If your problem statement defines temperature and pressure, then I can use this equation. If your problem statement defines entropy change and change in pressure, I should use this equation, enthalpy. So it depends on what is given in the problem statement. Based on that, we can select any equation. And that's why. The other thing is, why we have developed four equations? Why one equation is not enough? Because in most of the cases, S, one canonical variable is S, and in these two canonical variables, when we talk about entropy, it is not measurable. The other thing is, in case of volume you can measure, but it is little difficult to control of volume in actual. But you can easily control temperature and pressure in any system. So this would be more appropriate. That is the one reason. And the last question is like, which equation we should use at when? In most of the cases, temperature and pressure both are controllable parameters. So I can use the Gibbs free energy equation. So as for example, in multi-phase system, these two are easy to control as well as these two are constant. Volume will be different in case of multi-phase system. So Gibbs free energy will be the important property while we are studying multi-phase system. But in case of theoretical model, as for example, equation of state, any equation of state is written as a function of temperature and volume. Most of the equations of state are written in this form. Pressure as a function of temperature and volume. In that case, temperature and volume are more convenient variables to study. Here at the in the conclusion, I will say that in case of experimental data, temperature and pressure both are convenient variables. In case of theoretical modeling, temperature and volume are convenient variables. I hope that I have solved your questions. Thanks for watching this video.